Okay, hello again. This is the second part of the recorded for session for lecture 3. In the first part, we build the program to control the heater, turn on and off using the push button, start and stop push button, and also having an overheat switch to turn it off if the temperature is more than some threshold, and also we had some pilot lights to indicate that. But this time we are going to use HMI. When we have the HMI, in fact, we don't need to have physical switch because we can turn on and off the system or the heater using the HMI by having some switch on the HMI. And also we don't need some indicator pilot lights to indicate whether the heater is on and off. We can change the color of that, and this is something that we are going to build. So the program, in fact, simplifies to this part. This is the main part of the program that do the job, but the parts that are related to the indicator, we don't need them. The only device that must be connected to the input is the overhead. In fact, the devices that do some job in the machine, we cannot replace them by the HMI, like the motor, like the heater, like the sensors. But those devices that get the command from the operator, like the start and stop switches, or send some information to the operator as an indicator, for example, the switch, pilot lights, we can replace them, or we can have them in the HMI. So we don't need them anymore as a hardwire switches. Okay, so the program summarized to this one, and the connection are just simply overheat and the heater. And here you can see, let me show you on the here. Okay, here also you see that we don't need these pilot lights anymore. There's not any connection. I remove all the connection. We don't need this start and stop. We are going to move everything to the pilot, to the HMI, so we don't need these switches anymore. The only parts that are needed to still to be connected to the PLC are the motor, okay, instead of the heater, and also the switch that sense the temperature, so it's a sensor, and we should keep them here. We cannot replace that. So the wiring simplifies to this one. But all the communication with the PLC and from the operator and also indicators are going to be moved, replaced by the HMI. Okay, so let's again start from the scratch. TIA, again, administrator. Okay, create a new project. I'm not going to use the previous project. I'm going to build a new project. So let's call that heater control. Let's put an HMI after that to indicate that it is HMI. Okay, the version and everything, and the user is some values. Okay, and then create this. Okay. We have already done that, so I just go through that very fast to introduce the PLC just as a practice, but without that much explanation. Add a new device, so the CPU, then in this directory, this is the CPU that I have here, and then add that. But this time we are going to also add the HMI. So in addition to that, we need to add the HMI. So let's see, when the PLC has added, then just a moment. Okay. We studied in the lecture 2 that how to add the HMI, but let me just again explain that. There are two ways. One way is to use this add new device. The other way is to go to the portal view. This time I return to the portal view, okay, this familiar view. select the HMI. Here the display is 7 inches display, and it's a basic type, and the one that we have is this one. And the version of the software that I'm going to use is this one. So add that. Okay. Okay. Then it asked, regarding the HMI, it asked whether it's going to be connected to a PLC. Yes, let's connect that to our PLC. And then click on this icon. Okay, then next. If there are any selection regarding the header, I recommend to remove that. We don't need any header in our HMI. Also, anything regarding the alarms, we don't need that. If they are active, we don't need to add any root, any further screen. So there's not any further screen. Everything is in the root screen. We will have a practice to how to add some other screens, another screen for to the HMI, but in this example just the root screen, so everything is fine, and then finish. Okay, so right now we have the screen, the HMI. Let me zoom out. Okay, this is the HMI screen that we can build our HMI here. The HMI that we are going to build is this HMI, so we need a start and stop push button, so we need 2 switches, and also some boxes to color, some lines just to indicate that it is a heater, and also a switch and something to switch. All of these are built based on some basic elements. All these basic elements are available in your HMI here. Okay, here in this HMI window, if you click on the toolbox here, you see all the elements that are available. So we have these elements. These are very simple elements, but by combining them, we can build some complex elements. We're going to use these to build the elements, and also there are some basic objects and elements to build. Okay, so let's start with the very simple one, this one, the heater. It's just a rectangle, so I need a rectangle. Here is the rectangle. Okay, let me just a little bit increase the size. Okay, no, it's too much. Okay, this. We don't need this welcome message. You can simply select and remove that. Okay. So a rectangle, let's add a rectangle here. Okay, we can adjust the size of that. Here there are some information regarding that, regarding the color of that, okay, the color of the border, the color of the background, also the layout regarding the position of that, the width of that. Some other information that some of them we will use later. So, and also you can add some animation to that. This is something that we do. Animation is something that we can adjust the color according to the whether the heater is on or off. Okay, so let's first have this one. Also, this is something that I built by adding some lines, simple lines. It's too much here, but just to save the time, I built a few of them. Okay, just simple line here, and another line from here to here, for example, another line from here to, sorry, we can add another line, for example, from here to here, and then one from here to here, another one from here to here, okay, and one more from here, okay. And let me just skip to making all others. Just you can add any number that you prefer, and try to wrap up that at this point. Okay, this, and then have a line here, from here to here, and let me increase the size of this one. Okay, and then move all of them a little bit to left, to right, sorry, to, okay, this is the heater. It's not that beautiful, I know. You can make it more beautiful, and if you have time I will do that at the end of this session. But anyway, this is just, okay, we can change the size of that, for example, in the properties. Let me show you. In the appearance, you can change the thickness, the width of that. Okay, let me add, for example, like this, or the color of that, the layout regarding the width of that. Let me decrease that, and also I can increase the position, move the position. You can see here the position is changing, so make it more beautiful. Okay, that's good. And for example, this one also, let me change the appearance of that, increase the size, and also it seems that it is a little bit, it's not that straight, so let me, this is the how the distance in the x dimension. This is the x dimension, and this is the y dimension. This is dimension y, axis y, and this is axis x. The axis is 1, but it's supposed to be 0 because it's going to be straight. So let me just make it 0, and so you see it becomes very beautiful. And then let me decrease the size of that. Okay, and also move that downward. Okay, so move that. Sorry, change the position from Y. Okay, you see. Okay, and yeah, that's more beautiful. So you see that you can make it more beautiful. I skip this part, and if you have enough time at the end of this session, I make it more beautiful. But this works for us sufficiently. Shows that it is the heater. Just change the style of this one, increase this one, and then also let me check the layout of that. Yeah, 0, so it is quite straight. A little bit to left. That's good. And this one also, just this one. Again, the appearance of that, increase the width of that, make it more thick, and then the position from the X, let's move that a little bit to left. And you can also increase the size of that, okay? And move that to left. That's good, beautiful. Okay, so this is our heater. The heater is going to turn on and off to indicate whether the heater is on and off. So to do that, you can use change the color of that, depend on the state. According to the original program, if the heater is off, the color should be green, and if the heater is on, the color should be red. Okay, so instead of the pilots, red and green pilot lights, we are going to use the HMI. So let me change this in the HMI. How to do that? Okay. Here we have an animation. For this box, first select the rectangle, okay, and here we have the animation. We can change the color of that in this animation. But before doing that, we need to build the program. We need to have this program, and when we have this program, so we have these variables, and when we have these variables, we can change the color according to these variables. So before continuing HMI and for the other parts, let's first build this program and then use the variable address and the tag numbers of these PLC programs in our HMI to turn on and off or change the color of them. So let's go back to the PLC block, the main, and simply build the program. We have not yet connected to the establish the the connection between the PLC and the software completely. I can do that later. Just build the program, and then let's set up the configuration. So we need here 2, 3, okay, and one output, and here similarly we need a branch with this one. In the previous part we just dragged that to this point. This time I'm going to use this option. If you click on that, you see that it connects to the closest position upward. So here, okay, regarding the inputs, in the original program we had input number 1 and 0 because there was 2 switches, physical hardware switches that should be connected to the PLC through the inputs. But this time you're going to use the HMI for the start as the push button for the start and stop. So we don't need to use inputs because these are not devices outside of the control system to be connected to that. So instead of that, we use the memory, bit memory 1.0 and memory 1.1 for start and stop. So we only need to have, okay, here memory 1.0, 1. I think stop for 1, and so this is, let me use the same as it was here, 1.0 and that 1.1 for start and stop. Okay, so it should be, sorry, M1.0, okay, and change this to stop. See, there's not any input. You can change, and here it is M1.1, and this is supposed to be stop. Start. And this is for overheat. Overheat is connected, it's a sensor connected to the input 0.3. So we should keep that. And then this should be overheat. Okay. And this is the heater. Again, this is a we have a physical device outside 0.0, and then this would be sorry, heater. Okay, and again this is heater. Okay, so the program is ready. This is the only program that we need. Let me first compile that to see, be sure there's not any error on that. Okay, there's not any error. Okay, see here, there's not any error. So then let's download. This time, okay, it asks which PLC, and then I can set up the communication between the PLC. Okay, this is the IP. This is the PLC that right now I have in my software. You see that the address is not 205 because I didn't change that. So let me go back and configure the device from here. Okay, if you double click on this device configuration, this opens, and then if you double click on the PLC, here again that properties of the PLC opens. Under the Profinet Ethernet address, then go down to see, okay, this was the one that we had 207. It should be 207. Okay, apply that, and then again try to download. You see that this time the address is as it is given in the software, and then we can find for any available or compatible devices. Okay, yeah, this is the PLC that we have in the trainer. The address is this one, and then we can continue, say that, okay, select that. Has already been selected, so download that, load that. Okay, again, it reached to this point, continue without synchronization. And then again, it should be in the stop mode to change the program. So stop that because the PLC right now is in the stop mode, is in the run mode, let's say. And then load. Okay, and then start that. Okay, so the program is there, and but there's not any indicator there. And we should continue right now that the program is ready. We have enough all the addresses that we need in the HMI, so we can back to the HMI. The HMI under the screen. Please notice the HMI. So this is for the PLC. Let me close this branches for the PLC and instead HMI. Under HMI, under the screens, the root screen. Okay, under the screen, the root screen. Okay, double click on that. And this is the program that the screen that you just put. Okay, so select the rectangle. Okay, and then we can go to the animation, and here we have a display, and add a new animation. Something that we want is to change the appearance of that. Let's say the color of that. Visibility is that whether visible, it will be visible or invisible, but we don't want to make it invisible. We just want to change the color, so click on the appearance. Okay, then here let me drag it up so you can see more detail. Okay, the tag number, it's going to change the appearance, or it's going to change by the heater, according to the heater. So when you click here, it asks you the tag or the addresses under the PLC. Okay, under the PLC, find the PLC tags. If you click on this and the default tags, then you see, increase the size of that. Okay, you see all the tags that we have already defined in our PLC. Okay, in the PLC, we have input 3 for the overheat, Q00 for the heater, and these two memory bits that we are going to use as a start and stop. So the color of the heater is going to change by the color of this indicator for the heater is going to change according to the state of the heater command. Okay, if the heater command is 1, it's supposed to be red. If it is green, if it is 0, it's supposed to be green. So let's select that. When you select that, okay, it appears here. Then here you can add condition. Here, the heater, the state of that 0. Okay, heater is good. When the heater is 0, when the command of the heater Q00 or the command on the heater is 0, it means that the heater is off. In that case, you remember that the color is going to be supposed to be green. So let me select the green for that. This is green. Okay, then add new, and then by default, because this is just a bit, heater is a bit, it has just two states, state 0 and state 1, and it automatically show us the state 1, but you can also change that if you have other type of variables. Of course, for this one you have just state 0 and state 1, and when it is 1, when the heater is 1, it means that we have the command to the heater to be on, and in that case, remember that the color should be red. So let's select the color to be red. Okay, good. That's all. So it means that this box, the color, the background of this box change from green to red depending on whether the heater is on or off. Okay. So let me just, we will continue the rest. Okay, we need a start and a stop, sorry. We need a start and a stop. So let me add also the start and stop. For the start and stop, here we have some elements. The one that we need is this one, button. It is something that we can use as a button. So let me select, bring one here, okay, and one more also here, one for stop and the other for stop. Again, you can change the properties of that. Click on that, okay, double click, If the properties appear, that's fine. If it doesn't appear, just simply right click and then properties. Okay, so it appears. The text that we want to have here is this. We want start and stop. Okay, so first this is supposed to be a start. Okay, and okay, so this, okay, and the color of that is also going to change, and not only the color is going to be changed, but also the events. The events means that what to do, what's the command when you press that, when you active that by on the screen. So something that we want is this. Okay, let's look at that. By pressing, when we press that, it is a push button. It's going to be a push button. In the push button, when we press that, it is a start. When we press that, we expect that. Okay, let's look at the figure here and go. Sorry. Okay, it's going to replace the start push button, the physical start push button. The start push button, before pressing, it is 0. The state of that is 0. When we push that, the state becomes 1. The state of this input becomes 1. Again, when we release that, the state becomes 0. So this is something that we want to mimic. But instead of the input, in fact, that memory address is going to change. So memory address 1.1 is going to change when we press this push button. It's supposed to become 1, and when we release that, it's supposed to become 0. Okay. This is something that we can build here by using the event. When you press that, okay, select this press, and then add function. Something that we expect is this edit bits. Okay, there are many options. We are not going to go through all the details. We'll work with some of the details during this program, but not for this specific one. So here, just bit, set the bit. When we push that, when we press that, we expect that we set. Okay, set the bit. Which bit? Here. Okay, which bit? The bit, again here, if you click on that, it opens. By default, it shows you the tags in the HMI, but we don't have that tag still in the HMI. The one that we are looking for, that is this start. Okay, M1.1. So select that here. It means that when you press this start, the start tag M1.1 sets to 1. Okay, that's good. And then when you release that, the push button should return to 0. So the state of that should return to 0. So again, add the function, but this time the function that we need is the reset. Under the edit bits, the reset bit. So click on the reset bit, and then here again, start. Select the start. Okay. So it means that when you push this button in the physical HMI, the memory 1.1 becomes 1, and when you release that, it becomes 0. It is similar to what happens in a physical push button. When you push that, the state of this input becomes 1, and so the state of this start becomes 1. When you release that, it becomes 0. This is something exactly that is a function when you have, if you have a hardwire push button, or let's say physical push button. Similarly, here we have for HMI push button. Similarly for this one, the text of that is going to be stop, and similarly for the events, when we press that, add the function. This time, okay, let's have a look to this push button. This push button is a normally closed. So before pushing it is closed. When we push that, it opens. When we release that, it again closes. So when we push that, the state of the input is 0. When we release that, the state is 1. Okay? And this is something that we expect from the HMI push button. So this time, when we press that, when we push that, we expect to reset. Which bit? Bit that represent output. Stop, sorry, represent that stop. In the PLC tags, the stop, okay? Increase the size of the, so you can, okay, yeah. Input 1.0, so stop. So when we push that, it reset the stop memory, and when release that, it should set that. Okay, this time event bit events, select the set, and then under the set, select again the stop. Okay, and then check mark. So this time, when you push the stop, the stop push button in the HMI, the state of the stop in the PLC memory 1.1 becomes 0, and when you release becomes 1. It is similar to this. When you push, it becomes 0, it opens, and so the input becomes 0, and then we release, it closes, and so the state of this becomes 1. This is exactly something that we expect. But in addition to that, you can also change the color of that. The color, right now, it is just, the color doesn't change, but let me also change that. I add again the color. I want to also change the color and add a display, add a new animation, similarly appearance of that. This time again the tag is the start. The color is going to change with the start tag, and add new when this is 0. So before pushing, I just use this let's say this dark green, okay, and when you push that, okay, no, sorry, yeah, when you push that, the state of the start memory becomes 1. When we push the start, the state of this memory becomes 1, and when this pushed, I want to make it very light green, okay. Similarly for this one. For this one, again add under the animation, under the display, add a new animation, and this time again appearance. This is connected to the stop. I connect the color of that to the stop, and then if this is 0, if this is 0 means that you push that. Okay, the state of this bit, the state of this stop bit is 0, then we push the stop. And in that case, I want to have a light red here. So when it is 0, you select this light red, just it's up. And when it is 1, it means that when it is in release mode, let's select a dark red. Okay, that just. Okay, so by pushing and releasing that, this turns on and off. Okay. So let's, up to this point, let's download that. It's not yet finished, but just look at the result, just intermediate result, and then continue building that. So let's download that. First we should compile that. Click again on the compile to be sure that there's not any error on that. You see again, here it indicates that there's not any error, 0 error. There are some warnings, don't worry about them. Then download that. When we try to download again, it asks which HMI, and here, because we didn't set any IP for the HMI in the software, the default value is this. So let me cancel that. And again, in the HMI, under the HMI, double click on this device configuration. Okay, the HMI appears. Double click on the HMI, and here the properties of the HMI. Under the Profinet interface, Ethernet address, here goes down and find this. Okay, 192.168.0.20, but this 0.2, but this is supposed to be 205. Okay, so I set an IP for my HMI. It is in this software. It is not yet in the PLC. Of course, the PLC has also the same IP, but anyway, it is not yet defined in the PLC. It is just in the HMI. It is just defined in the software. Then again, let me select the HMI and download that. This time, you see, it mentions. So let's, instead of say compatible with exactly the same address, use this option. So if the address is exactly the same, this will be shown, indicated here. Start search. Okay. Yes, it is here. So load on that. Okay, this is the HMI. Okay, let me, before going through that the detail, show you something here. It's a little bit more closer to that. On the HMI, in the home screen of that, you have transfer, start, and setting. Start means that it goes to the HMI that has already been downloaded. Under the setting, there are some options that we also look at that in the second lecture. And in the transfer is the one that you can see whether the transfer is correct or not. The transfer. So let me select this part and then continue downloading. Okay. During the download, it asks whether I want to overwrite the HMI, the HMI that we built on this HMI device, because this HMI device, there's some HMI has already downloaded on that, but I want to overwrite. I want to overwrite my own HMI on that. So click on the overwrite and then load. And here you can see it's mentioned that it is sorry, didn't see that. Yeah, sorry. Okay, so this is the HMI. This is the simple HMI that we built. This is the start, this is the stop, and this is green. Okay, and right now, the light for this is green. It's a little bit. It's not possible to go any further closer to that. This is better. Yeah, this is better. Okay, a little bit close. So here you see the start and the stop. It is in green and red, and this is also in green. So then let me push the start. Okay, see that the color for the start becomes red and green. Okay, it becomes green, but the heater doesn't turn on. So it means that there's something wrong on that. What's that? Look at this stop, and let me push this stop. Okay, the stop was on. Yeah. No, the stop is on. So it means that according to the color that we defined, the dark red means that the stop push button is not pushed. The initial state of that is one. And this is, so let me push this and push this. Okay, so these two push buttons are working correctly. But why the heater doesn't turn on? Okay, to look at that, to investigate that, let's look at the program, the PLC program. Okay. in the PLC program, let's monitor the state of the switches here. You see that, okay, the stop is on, that's good. The start is off, okay? And then when I push this, you see that? When I push this, this turns on. So the problem is on the overheat. The overheat switch is on, is open. It means that it looks like that the overheat, there's an overheat on that. So let me change the state, okay, show you here. Okay, so this switch, in fact, is off. So let me turn it on, okay? When I turn it on, here you see that it becomes green. So no, there's not any overheat. And then if I push the start, you see that the motor, okay, you can hear the motor is on. Okay, let me show you. The motor is on. Okay, the motor is on. It's turning. And also you see that the heater indicates that it is on, it is red. So it is on. So instead of having a pilot light for indicating the state of the heater, you can indicate that on the HMI. You don't need any wire. Let me stop that. Okay, stop that. And again, start that. Okay, adjust this a little bit. Go back. So, you have the motor, you have the overheat, start, and this is the indicator for the heater. So, start. Start. Okay, so you see. Okay, but we want to continue to improve this HMI. So let's back to the HMI. It works well, but it's not yet complete. Something that we need is this to have an indicator for this switch, the state of the switch. So a sensor and a state of the switch here. Okay. So let's build this part also. To do that, okay, I just add a circle, small circle here to indicate that's the switch. Okay, a little bit. Okay, and make it the color of that. Okay, appearance. The fill pattern of that, the color to be black. Okay, another one of these. I can Control C and Control V. Okay, just copy that. So okay, these two dots, and then the rest, the line here, just to indicate that this is connected to down, and increase the width of that. Okay, that's sufficient. This is the switch. The switch has one line from here to this point. Increase the width of that. This is the switch. Okay. And also we need, let me stop this. Okay, stop that. And then to build this part, okay, this sensor shape, I add rectangle 3 rectangle, one for this center one and 2 for these small ones, and line, and a line here. Okay, so let me add a small rectangle here, long one, okay, and one more rectangle here, and one more rectangle here. Okay, let's increase the size. Okay, you see they are not that beautiful, so I just select this, and then in the layout we need to increase the width of that. Okay, oh, too much, just 1 point, yeah, sufficient. And also move that a little bit upward, so by changing the y-axis, oh, it connected. Okay, similarly for this one, so let's use the same 11 by 5, so use the same for this one also, 11 by 5. Okay, but also I should move that a little bit to right up, not too much, right, and a little bit down. Yeah, it's connected. Okay, so these are connected. Then I need also a line from here to here to indicate that the sensor, this is a sensor switch. Okay, and a little bit to left. So that's beautiful. Okay, everything is here. This center rectangle is going to, the color of that is going to be changed. We assume that if there's not any overload, the color is going to be light yellow, or maybe just let's keep it gray, and when there's an overload, change this color to the orange. So this time, okay, I select this rectangle, and then in the animation, add a new animation, double click on that, select appearance, we are going to change the color of that, so then okay, and then the color is going to be changed according to the overheat. So select under the PLC tag, select the overheat. Okay, if there is overheat, please notice the overheat is a normally closed switch. So in normal state, it means that when there's not overheat, the switch is closed. Let me show you again here. Okay, here. When there's not any overheat, the switch is closed. This dash shows that it is a normally closed. It means that in normal state, when there's not overheat, this is an overheat. It's going to sense the overheat. So if there's not any overheat, this is closed. And in that case, so when the state of this switch is 1, when the state of this switch is 1, something that we expect is that the color, there's not any overheat, so and when when the overheat happens, the state of this input becomes 0. When there is an overheat, we expect that the color to change to orange. Okay, but if there's not any overheat, when the state of that is 1, we expect the color to be gray. But let's use another gray, a little bit dark gray, like this. Okay, a little bit darker gray. So the state of this is dark gray when there's not any overheat, and the state of that is orange. The color of that is orange when there is overheat. But in addition, we want to indicate that in this switch. Here you see that the switch is connected. Oh, let me just a little bit bring it down to, oops, sorry, it is connected. Something that we want is to indicate that to the operator, so operator can, yeah, this is better. Okay, this is close. But something that we want to show to the operator is that when there's an overheat, the switch opens like this. Okay, here when there's an overheat, this is orange, and also the switch opens. How to do that? In fact, we don't have this option to rotate the line in this PLC HMI basic objects, but we can we have another option. The option is that we can have another line here. Okay, let me add another line here. Good. And also let me increase the width of that, the appearance of that to be same. Something that we have, okay, now we have two lines. This line is going to be appear to be visible when there's not overheat. And when there's overheat, we can invisible that. We can just invisible that. And this one, opposite. When there's overheat, this is visible, and when there's not any, it's not overheat, it is invisible. To do that, let's select this one, for example, and then in the animation, this time, again, add new animation, use this visibility. Okay, let's use this visibility. Okay, and then again, it depends on the tag, depends on the overheat. Okay, what we expect that it is visible. See that you have two options, visible and invisible, both of them. It's going to be visible if there is not any overheat. When there's not any overheat, the state of this overheat variable is 1. So when it is 1, from 1 to 1, it gives you more range, because here we have just bit. It is bit just two states, 0 and 1. But later we will study analog signals and word variables, then there's a range on them. So you can also have some range. In some range it is visible, in some range it is invisible. But in this switch, the state of the overheat is just a bit. The state of that is 0 or 1. When this is 1, it is visible. Otherwise it is invisible. For the other one, it is opposite. For this one, it is opposite. So let me add an animation to that. This time, visibility is opposite. So again, select visibility, and then again using the visibility is going to be changed according to the overheat. Okay, so the overheat, this time, it is going to be visible when there's overheat. When there's overheat, this variable, the input variable, overheat variable, the input variable is 0. So when it is 0, it's going to be visible. Okay, it's going to be visible. And then, yeah, there's one more minor change, but let me leave that to final tuning of the HMI. Let's download this and see the effect of that, and then do some minor improvement on the HMI. So this time again, there's not any error, and download that. Okay, let me show something here before look at this point. So let me download. Just a moment. Again, overwrite, yes, because we are going to change that. Load, and then okay. Look at here. You see that? Okay, this transfer menu opens and shows if there's any error, it indicates some error. And here, okay, you see that the switch is also added. The switch is also added, and this time let's again run the program. So let me start that. Okay, okay, again the motor turns on, say the heater turns on, and it indicated by right here. Then I stop that. It is green. The overheat switch is closed. It means that there's not any overheat, and you see that the color of this one is also gray. Okay, it is here, and then again start. Okay, please. And this time, let's assume that overheat happens. So let me switch this off as if overheat happens. Okay, you see that the color changed to orange. I hope this is clear. And the switch also indicates that it is on. Okay, and when the temperature reduces, the heater turns off. So the temperature, we expect that reduces after some time. When the temperature reduces, so the temperature becomes less than, drops to less than the saturation or the switch temperature limit, and then this turns on. You see that? Okay, it shows that there's not any overheat, both on the color of the sensor and also on the switch. So, okay, see, this shows overheat, and this doesn't. It shows that there's not any overheat. And here, you see that when there's any overheat, I cannot turn it on. I push the stop, but it doesn't turn. Okay, I push the stop, doesn't turn. But if there's not any overheat, then you can turn it on. Okay, good, beautiful. So that's all. We can also do some minor modification at this point to make it more beautiful. So that's all. This is a simple HMI, but you see that you have the ability, the HMI gives you this ability to remove the switches, and it is very important because each switches are going to be connected to the input outputs. If you can reduce the number of the input outputs terminals that you need in the PLC, so you don't need, for example, anymore that reduce the number of the input output cards to be added, and also wiring. All of them are costly. Wiring is costly, switches are costly, and there are some also the cards, input output, external input output cards has some cost. So by using an HMI, you not only have more flexibility but also reduce the cost. Of course, for small scale project, maybe maybe HMI is more expensive using HMI. But when you have a medium scale and larger scale HMI, this decrease on the price is significant. Okay, that's all.